Class, welcome back to our next video. We're getting towards the end here. We're close to the finish line. Today we are going to focus on logarithmic graphs and then also just a little bit of work on inverses. Okay, we'll jump to inverses stuff in a little bit. Let's first cover graphing when we have logarithmic graphs. Now, hopefully you remember that we cannot take logs of negative or zero arguments. Okay, the arguments must be greater than zero. Now what I want you to realize and kind of recognize what makes this a logarithmic graph is that it turns out that x is going to be our argument everywhere. So that means that x cannot be negative or zero. So we'll cover that in a little bit. Now, let's think back. We practiced a little bit last week on finding some nice points. We knew that if we rewrote this and we wanted to find the log base 6 of 1, well, what exponent do you have to raise 6 to in order to get to 1? 6 to the 0th power gets you 1, and 6 to the what power gets you 6? Well, 1. Alright, so we were able to plot these, or figure out these nice points, and then we were able to plot them. So here we are at the origin. I have to plot 1, 0. I have to plot 6, 1. The last thing that I need you to think about here, guys, is that I cannot have an argument that is negative or 0 for that matter. Okay, so think about this. X cannot be 0, and it cannot be negative, which means it has to be positive. So what do you think I have to draw? Because x has to be greater than 0. I hope you said a vertical asymptote. Alright, I need to draw a vertical asymptote right along the y-axis, and the reason again is because I know that my argument has to be greater than 0. It cannot be 0, it cannot be less than 0, it must be greater than 0, or to the right of 0. So now that I have that vertical asymptote drawn in, I can go ahead and I can sketch this. Something like this, and that should be good for this picture. Similarly, in this next one, I want to do this one the same way. Again, the points are nice to find, right? 10 to the what equals 1? 0. 10 to the what equals 10? 1. So again, I have my points. I have 1, 0, I have 10, 1, and again, I know that there is going to have to be a vertical asymptote. Hopefully you guys can explain to me why we need a vertical asymptote. Make sure to be able, like if I ask you tomorrow, make sure to be able to have a good explanation. But once you have it, you do the very best you can to sketch using your vertical asymptote and your couple of points. Now, on this last one, I want to give you guys another method. I want to give you another method. I saw a couple of kids doing it, which was awesome because it's what we did over the summer. It also might be helpful for when we jump into some harder logarithm graphs, alright? And what I mean by this is, I am going to change this. I'm going to change this. Right now, I'm in log form. My x is in log form. And sometimes I have trouble plugging in x values into the argument of a logarithm. So what I'm going to do is I'm going to show you what we can do is if we use our log circle, right, or if we convert this from log to exponent form, it's going to end up being, I'll cross this off, it's going to end up being something like this. I'm going to get e to the y is equal to x. Alright, now what's really nice about this, guys, is I now see a place where I can plug in numbers very nicely, and I know exactly how to work with them. Now let me ask you, do you think that value is the y value or the x value? I hope you said y. I know exactly what to do because this is now exponential form, and I'm really good at graphing exponential form. I know that I can plug in nice numbers such as -1, 0, and 1. The only thing you have to be really careful of is, again, this is the y value. So I am not blindly putting -1, 0, and 1 in for my x column. I am going to put them in for the y column. Okay? Because now I can go ahead and I can get these values. E to the 0 is 1. E to the 1 is e. E to the -1 is 1 over e. Alright, and I can plot these points. What's really nice, guys, is if you had just done it the old way, you still would have gotten these 2 points that we got using this method. So again, on something nice and easy, kind of like the original here, I'm okay with you using your graphing techniques that we learned a couple of videos ago. I just think this is a nice method, especially for when we get into some tougher graphs in a little bit. So I would plot all these points, 1, 0, e, 1 is like 2.7, 1, 1 over e, -1, I don't know, something like that. And now, again, I would understand what this graph should look like. I have to get all my points, and then I know that it goes up and out forever. Alright? Okay. Let's move on. All of those logs had base greater than 1. Now let's take a look at some that have base between 0 and 1. I'm going to do the first one with the old method. I'm going to do the second one with the new. I know that if I wanted to plug in 1 for x, 1/2 to the what power is equal to 1? Well, that's always going to be 0. 1/2 to the what power gets me to 2. I believe that's a -1. Alright, the other one that we could plot is we could say 1/2 to the what power is equal to 1/2. Well, that's where we get our 1. So now we could plot these 3 points, 1, 0, 1/2, 1, 2, -1, and now I can see what's going on. Bad asymptote. But now I can see that my curve is doing one of these. Perfect. What do we see as the difference here? It looks like logs with base greater than 1 should be rising as x increases. And it looks that when our base is between 0 and 1, our graph is going to be descending. Decay. Alright. Now in this next one I said I wanted to do it the other way. So I'm going to go ahead and I'm going to rewrite this as an exponential. Alright. The reason I do this is because I remember that when I have exponentials I can always nicely plug in -1, 0, and 1 for the exponents. That's the important part. It's for the exponents. So that in this case is going to be our y column. Now when we solve, well, we get 1, 0. When I plug in 1, I get 1/5. When I plug in -1, I get +5. I can plot these points. So 1, 0, 1/5, +1. That's hard to graph. 5, -1 is not too bad. So now I could sketch. Again, I need my vertical asymptote because our argument must be greater than 0. But then it's as easy as just connecting the dots like that. Okay? Alright, let's move on. Alright. Alright, my two graphs up at the top are very similarly related. Only major difference is one has a positive argument, one has a negative argument. Now, again, we can't have negative arguments. Don't think that this is impossible, though. We just need to remember that we have to do something, or the x values that we choose have to make the argument at the end positive. All right. So if I had log base 3 of x, a couple of options, you could go 3 to the y equals x, you could go negative 1, 0, 1. So I know 1, 3, and then 1/3. So I could plot my points. 1, 0, 3, 1, 1/3 negative 1. And I could sketch. Now, one thing that I want you to keep in mind here, we already know that when you have a negative inside the function, what's it supposed to do? It's supposed to flip over the y-axis, right? So if you feel confident enough and you feel like you understand this, then I am completely okay with you just flipping the values, flipping it over the y-axis. Now what I'm here to say though is look at what happens when I do this. So now if I go to exponential form, right, I use my log circle. Alright, now what I want to do here is I actually want to move my negative to the other side. So negative 3 to the y is equal to positive x. So now when I go ahead and I make my table, still negative 1, 0, 1 for my y values. When I plug in 0, I'm going to get negative 1. When I plug in 1, I'm going to get negative 3. When I plug in negative 1, I'm going to get negative 1/3. And what do you know? That does the flip that I expected to see for me. Alright, I now have my graph opening to the left. Now that should hopefully make sense. We know that we can never have a negative argument, right? Well, what if I plugged in positive 1, excuse me. If I plugged in positive 1 here, that would make my argument negative, and then I wouldn't be able to I couldn't graph it, okay? That's undefined. So here we go. That is what we're looking at, and with two different options. Again, if you see that it's a flip, then you can just flip this. If you don't see that it's just a flip, or you're really struggling with that concept, or you don't know the points, well then change it into exponential form and turn it into something that's nice to plug in numbers for, okay? Same thing's going to happen down on this next one. Y equals all in x. I am going to say, well, e to the y equals x. How did I get it? Because my base is and I log circle. So negative 1, 0, 1, 1, e, 1 over e. When I go and plot, I get 1, 0, 2.7-ish, 1, something like that, and I can sketch. Well, what happens on this next one? I cannot use a log circle yet because I don't have a log by itself. So the first thing I would have to do is make my negative kind of come over here. But now I am in a perfect spot to log circle. So now I have e to the negative y is equal to x, and you guessed it, I'm going to make a table. When I make my table, I'm still using my nice y values, or my nice exponent values, in the y column. Why? Because y is the exponent. And so let's see, well that's when I plug in negative 0, that's still just 0, so 1. E to the negative first is 1 over e. E to the negative first is e to the first, or e. So now I can plot my points. 1, 0. E, or 2.7, negative 1, 1 over e, positive 1, and I know that my curve will look something like this. And I make my asymptote. Alright. Now what happened? Oh my gosh. Just what we hopefully should have thought happened. This negative out in front, outside of the function, should have shown us a flip over x-axis. And did it? It absolutely did. It took any point that I originally had on my original curve, and it flipped the sign, flipped the y value. So now it was flipped over the x-axis. Alright? Okay. We're getting there. We are getting there. All right, last couple of graphs, at least for the time being. Here we go. We got one. We got another. I'm going 1 over 4 to the y is equal to x. So again, I have xy, negative 1, 0, 1. Anything to the 0th power is 1. Anything to the first power is itself. Anything to the negative first is the reciprocal. So now I have some nice points that I can plot for my original graph. So 1/4, comma 1, 4 to the negative 1, and I can sketch. Okay. Uh-oh. Okay, a little bit different here. This is when you have your options, you have your choice. Just like up above, if you recognize that this is a, if this is a flip over y-axis, then you are more than welcome to get these points and flip it over the y-axis, right? It would make any x value a negative x value. I just want you to understand that you can also do something like this. So we have our log, so we can go 1/4 to the y is equal to negative x. But I would want you to just remember that it's going to be way easier. Like for plugging in y values, I would want anything that has to do with evaluating on the same side as the y. So I would make this negative 1/4 to the y is equal to positive x, and now I could make my table. It would still be negative 1, 0, 1. The only difference, though, when I take 1/4 and I raise it to the 0th power, which is 1, I have to make it negative. So negative 1, and negative 1/4, and negative 4, which is exactly what I thought would happen, right? We thought that it would just take our original x values and make them negative, and it did. Okay, so now we would plot negative 4, comma negative 1, negative 1, comma 0, negative 1/4, positive 1, and I would sketch something like, not the best, but it'll get the job done. Okay, make sure you guys are hugging the asymptote a little better than I am. Okay, all right. Okay, last little topic on this video is a little bit of a refresher, but I want to show you guys kind of what we're doing here. Excuse me. Exponents and logarithms are inverse functions of each other, okay? We need to remember this. Because they are inverses of each other, we need to remember that they should reflect over what line and become the other one? Y equals x. Alright, so what we're going to do is we're going to take a look at that and see if it works out. Well, y equals 2 to the x. This is exponential already. And my x is my exponent, so that's where I'll put my negative 1, 0, and 1. So 2 to the 0 is 1. 2 to the first is 2. 2 to the negative 1 is 1/2. So now I could go ahead and I could plot these points, right? 1, comma 2, 0, comma 1, negative 1, 1/2. And I would see that I would have something like this. Now what happens when I switch? When I move over, I'm not ready necessarily, if I want to use my table method at least, I would want to rewrite this as 2 to the y is equal to x. Alright, so now I know that my negative 1, 0, and 1 go over here in the y column, and now 2 to the first, 2 to the 0 is 1, 2 to the first is 2, 2 to the negative first is 1/2. So when I plot these, 1/2, negative 1, 1, comma 0, 2, comma 1, and now I would have something that looks like this. Alright, now I should have my vertical asymptote. I should have my horizontal asymptote for an exponential. And the last thing I would want you guys to recognize is what happened. It did exactly what we thought. It looks exactly flipped over y equals x. Beautiful. So that's exactly what we thought would happen, all right? That should happen every single time. Now the only thing that I need you to kind of say for finding an inverse, it's the exact same thing as we did before. To find an inverse, you switch x and y. All right, you switch x and y. So let's take y is equal to log base 2 of x, for example. So I would switch that to x equals log base 2 of y. And then I would solve for y, which means, oh, right now I have a log. The variable I want to solve for is stuck in the argument, which means I would need to log circle. So how would I do this? It would be 2 to the x equals y. And oh my gosh, that's exactly what I got over here. That means that these two things are inverses of each other. Okay? Okay, last thing for this video, I'm going to have you guys try a couple of things on your own on the next page, page 38. That shouldn't take too long, but I do want to talk one little bit about transformations, shifts. All right. So far, we've only really done flips. We haven't done any shifting. I want you to understand that it's really similar to what we did with exponentials. All right. Please note, please note, x minus 4. X minus 4. This minus 4 is inside the function, which means this is an x shift or a horizontal shift of 4 right. Okay, we're shifting 4 units to the right. So this is what I do. This is what I do. I take care of that shift right at the start. I now know 1, 2, 3, 4. I now know, that this is technically like my new origin. So what is it going to have? Well, I know that this is a logarithmic graph, so it's going to have a vertical asymptote at that origin. So I can plot that or sketch that in already. What I need to remember next, though, is basically I'm graphing log of x with this shift, right? So I really need to do y equals log of x, because basically I'm predetermining where I'm positioned because of this minus 4. So I'm almost like getting rid of it, moving it. Sorry, let me rephrase that. I'm moving it and then getting rid of the minus 4. So this would be 10 to the y is equal to x, x, y, and I would have negative 1, 0, 1 for my y's, so I have 1, 10, and 1/10. Now please remember, these are from my new origin, right? So if this is my new origin, then I know I'm going 1 over to the right, up, down 0. I would be going over 10 to the right and up 1. And then I'd be going over 1/10 and down 1, something like this. Not a dashed, sorry. So something like that. All right. Now my domain, you can do this two ways. You can look at it graphically and you can say, well, if my vertical asymptote is at x equals 4, well then x must be greater than 4. The other way to do it, guys, is algebraically, right? We knew that x minus 4, the argument has to be greater than 0. Oh my gosh, we get the exact same thing as the graph. So that's cool. Range, I hope you agree. This is going down forever, and even though it's kind of going to it looks like it's going more right, it is going up forever. So, all real numbers, and then of course vertical asymptote, x equals 4. Alright, this is definitely long enough. Let's pause here. Let's see here. On this next page, this is what I would like you guys to do. I would like you to give this page a try. Alright? I would like you to see and practice trying to find an inverse of a function, and then seeing if you can graph both the original, which is exponential, as well as the log, which is what the inverse will be. All right? So let's finish up there. I hope you're doing okay. I hope this is making sense. I hope that trick with changing from log to exponent form comes in handy. And I will see you guys next time to practice. Later.